Let's explore how detailed animations help us understand mathematical concepts more deeply. Animations transform abstract mathematical ideas into concrete visual experiences that enhance understanding and retention. Let's understand why visual animations are so powerful for learning mathematics. Research shows that our brains process visual information 60,000 times faster than text alone. Unlike static images, animations reveal the dynamic processes behind mathematical transformations. Animations bridge the gap between abstract mathematical concepts and concrete visual understanding. Let's see how animations help us understand function transformations. Consider the basic quadratic function f of x equals x squared. Here's the graph of y equals x squared, showing its characteristic parabolic shape. Now let's transform it to g of x equals quantity x minus 2 squared plus 1. The animation shows how the original parabola shifts right by 2 units and up by 1 unit to create the new function. Derivatives become clearer when we animate the concept of instantaneous rate of change. The derivative is the limit as h approaches 0 of the difference quotient. We start with a secant line connecting 2 points on the curve. As the second point approaches the first, the secant line becomes a tangent line representing the instantaneous rate of change. Integration becomes intuitive when we animate the accumulation of area under curves. The definite integral represents the total area under the curve from A to B. We approximate the area using rectangles, which is the fundamental idea behind Riemann sums. As we use more rectangles with smaller widths, we approach the true area under the curve, which is the exact value of the integral. Vector mathematics becomes much clearer with visual animations showing operations in space. Here are 2 vectors, A in pink and B in blue, starting from the origin. Vector addition places the tail of B at the head of A, and the sum is the vector from the origin to the final point. Complex number operations become beautiful when visualized as transformations in the plane. Consider the complex number z equals 2 plus I. We can represent this complex number as a point or vector in the complex plane. Multiplying by I rotates the number by 90 degrees counterclockwise. The animation shows the 90-degree rotation that occurs when we multiply by I, transforming 2 plus I into -1 plus 2I. Matrix operations represent geometric transformations that become clear through animation. Consider this transformation matrix that scales the x direction by 2. We start with a grid of points and the standard basis vectors. The transformation stretches the entire space horizontally by a factor of 2, while leaving vertical distances unchanged. Let's review the power of detailed mathematical animations. Animations reveal the dynamic processes behind mathematical concepts, not just static final results. Visual representations dramatically accelerate both understanding and long-term retention of mathematical ideas. Even complex mathematical transformations become intuitive and accessible when shown through smooth motion. Ultimately, animation serves as the bridge between abstract mathematical symbols and concrete visual understanding.